Hello everybody, we're going to talk about comparing linear and nonlinear functions. So a graph of a linear function shows a constant rate of change. A nonlinear function does not have a constant rate of change, so the graph is not aligned. So anything that looks like this, that should be a straight line by the way, anything that looks like that is going to be linear. And then things that look like this are not linear, okay? So, does the table represent a linear or nonlinear function? Okay, so 340, 632, 924, 12, 16. So how can you tell without graphing? Because those are big points. Who wants to graph all that, right? Well, you can see the rate of change here is 3. And the rate of change here is 8. Rate of change here is 3. Rate of change here is 8. Change is 3. Change is 8. So that's going to be linear. Okay. You could also pick any 2 points that you wanted on here. You could select. So say I took this one, and I found the slope. So that'd be 40 minus 24. Over 3 minus 9. So that would be, 16 on the top, and that would be negative 6 on the bottom, and that ends up being negative 8/3, okay? So then if I chose a different set of points, so say I chose these two this time, that'd be 32 minus 16 over 6 minus 12. And I'm going to get, again, 16 on the top, and I'm going to get, negative 6 on the bottom, which is negative 8/3. And you could pick a different combination that I didn't choose. You could pick these two, or you could pick those two, and you're going to get negative 8/3 every time. So this is definitely linear. Okay? The slope is the same. The rate of change is the same no matter where I choose it. Now, if I look at this one, this changes by 2, this changes by 2, this changes by 2. Okay, so that's okay. This changes by 9, this changes by 11. That tells me right now this thing is not linear. And then it gets even worse here. This changes by 55. Okay, so if I did it the other way, and let's say I calculated the slope from here to here. So that would be 11 minus 2 over 3 minus 1, which would be 9 over 2. Okay. Now, if I calculate the slope from here to here, that's going to be 88 minus 33 over 7 minus 5, which the bottom is still 2, but the top is now 55. Okay, this thing's getting steeper as you go this direction. So this is not linear right here. The slope changed. Okie doke. Does the graph represent a linear or nonlinear function? Well, that's pretty obvious. I think this one's definitely linear. And how do you tell? Well, it's a line for one thing. And the slope on this one is very simple. The slope is 0, and it's always 0. Okay? You look at this one, this is curved. Okay? So that tells you right away it's not linear. Okay? And second of all, if you were to calculate the slope, I mean, you look here, the slope's positive. Okay? And it's steep. But now the slope is still positive, but now it's not steep anymore. Here the slope is 0. Okay, and then the slope is getting bigger again, and it's getting steeper and steeper and steeper. So the slope changes, which means it's not linear. Okay, now you do these. Does the table or graph represent a linear or nonlinear function? So go ahead and pause the video, do these 3 problems, determine if they're linear or not, and then jump back on and see if you got it right. Okay, over here, if I look at this one, the x's change by 7 each time, which means that this should change by the same each time. So this changes by -5, by -5, and by negative 5. So this is definitely linear. Okay, over here, this changes by 2, by 2, and by 2. This changes by negative 4, by negative 4, by negative 4. So guess what? This one is also linear. Okay, this one you can look at it and you can say, well, obviously this is not linear because it doesn't form a line. Okay, so this one's not linear as a whole. Now here's the thing. If I look at this part of it right here, this part is linear and this part is linear. But the whole thing is not linear because the slope over here is positive and the slope over here is negative. Okay. Which equation represents a nonlinear function? So let's look at these. Y equals 4.7. What is that? That is a horizontal line at 4.7. That thing looks like this. Okay, if I was going to put it on a graph, this right here would be 4.7. So that's definitely, this is linear. That can't be it. Okay, y equals pi x. Okay, well, this is just y equals mx plus b, which is a line. The y-intercept happens to be 0, and the slope is pi. So yes, this is also a linear function, so we can cross that one off. Okay, this one here, y equals 4 over x. I cannot write that in slope-intercept form. This is not a line. This thing, as x gets bigger, the fraction gets smaller, okay, and it has a different slope each time. So this is going to be our answer right here, C. Now there might be two answers to this, so let's look at this last one here. This one I would go ahead and distribute this in here. So I would get y equals 4x minus 4. Well, that's just slope-intercept form, so that's a line. That one's out as well. Okay, if I were to graph this one, by the way, here's what it's going to look like. Is it's going to look like this. So definitely not linear. Okay, let's look at this. An account A earns simple interest. Account B earns compound interest. The table shows the balances for 5 years. Graph the data and compare the graphs. Okay, so if we look here at just this part right here, okay, this goes up by 1 each year. This goes up by $10 each year. This is definitely linear, okay? So this part right here, linear. Okay, if I look at, let's say we look at this column here, and this column over here, okay, this still goes up by 1 each year. This goes up by 10, this goes up by 11, this goes up by 12.1. This is not linear. This is getting steeper and steeper because this is compound interest. It means I'm getting interest on my interest. Okay, so this one went up 1331 and so on. So here's what's going to happen with this. If you graph these, they went ahead and graphed it for you. Here's the linear one. Here's your simple interest. Okay. Now the red one is account B. This is compound interest, and it stays this. It looks like it stays the same almost for a little while, but it's going to curve up and up and up, and it's going to just take off from here. Okay. It reaches a certain point, and it's going to grow much, much faster than simple interest, which is always why when somebody's paying you interest, you always want to get compound interest. If you're paying interest, you want to pay simple interest. It's also why people get in trouble with credit cards really easy, because you're looking at interest rates of 15%. And so what ends up happening is this curve gets curved really steep, really fast. And you can get behind and messed up really quickly with that. Okay, does the equation represent linear or nonlinear function? Well, I tell you what, why don't you pause this video, you guess which ones are going to be which, make a reason for why you think your guess is correct. Okay, so basically explain why you chose it was linear or not, and then jump back on here and see how you did. Okay, y equals x plus 5. This is definitely linear. Okay, this is a line with a slope of 1 and a y-intercept of 5. So if I was going to graph this thing, it would look just like this. Except this would be a straight line. That's better. Okay. Now, here's the one that's a little bit tricky for people. Is this thing linear? And the answer is yes, this is linear. And some people get confused by that because the way it's written, if you wrote it like this is the same thing. And that's definitely in slope-intercept form, y equals mx plus 0. So the y-intercept is 0, the slope is 4/3. Okay, so if I was going to graph this thing, okay, this thing would go from here to here, up like that. Okay, this last one. Is this going to be linear? And the answer to that is no, because we don't have x squareds in lines, okay? So this is actually a parabola, so this is nonlinear. Okay, a little later on you'll learn how to analyze this a little bit, so you'll realize, hey, this is an upside down parabola with a y-intercept of 1. So this thing is going to look just like this. Okay, definitely nonlinear. Okay, you're going to get to do 1 through 21, the odd ones in class next time. I'll talk to you guys later. Have a good evening.